Hello, my name is Oliver Maiß and I lead the Research and Development Department here at ECOROLL AG. Today, I would like to tell you something about thread rolling and how you can significantly increase the strength of your threads. Highly stressed threads are found everywhere in mechanical engineering. Whether in mobility, general mechanical engineering, or energy technology, everywhere, components need to be firmly and securely connected. This naturally places a very high demand on the thread connection, because if they fail, the components that are supposed to be firmly connected will, of course, lose their connection. Therefore, very high demands are placed on the strength of these screw connections. Thread manufacturing can be done in two different ways. We have thread cutting and thread forming or thread rolling. In thread cutting, the shape of the thread is created through a machining process. That means the material is removed and the thread is machined in such a way that the shape meets the required standard. This method is very flexible and can produce threads with a wide range of variations. This means we have threads of different sizes. We can produce very large and very small threads. We can produce special threads or standard threads. We can produce trapezoidal or API threads. All of this is very efficiently possible and can be used on any machine. In thread rolling, we are in the area of mass production. Here, the threads are produced through a forming process. Produced by rolling, this means the material is deformed in such a way that the thread shape is formed at the end. This process is highly efficient, very precise, and particularly well suited for mass production. LMT is a good contact if you have questions about the process. I would like to briefly mention the company here because they have greatly supported us in this project. When rolling threads, it is known that increased strength is achieved. This means that formed threads are more stable or resistant to vibration than cut threads. However, there is another process in between called thread rolling. In thread rolling, a cut thread is subsequently reinforced. This means we introduce compressive residual stresses into the thread root and reinforce the thread root, precisely where the highest loads occur in the thread, additionally strengthening the thread. This process is of course also very flexible. I can use it in any machine. And above all, I can use it for any type of thread. Here too, I can again standard threads, special threads, API threads, trapezoidal threads, all of these can be subsequently reinforced by rolling. We now wanted to know how much the fatigue strength depends on the manufacturing process. I just mentioned that with thread rolling or rolling, we have increased strength. That means compared to machining, rolling already has an advantage in terms of fatigue strength. But how exactly does the rolling fit in there, and how can it be measured? For this, we conducted a joint student project with the University of Esslingen, where we analyzed the fatigue strength of these three types of threads. To carry this out or to gain this insight, we oriented ourselves to the standard and conducted a fatigue strength analysis. Approximated to DIN 969, which is the standard used for determining the strength of screws. Of course, within the scope of a student project, we cannot fully comply with the entire standard, but we have closely followed the standard on the important points. And in the area of the clamping of the threads, the application of the load, the test cycles, all of that, we closely followed the standard to achieve a reliable result here. We manufactured the threaded rods here, an M12 thread from a 42 chromo 4, tested in a resonance testing machine and then recorded various Wöhler curves. I would like to explain the thread rolling process separately once more. In thread rolling, we used a single roll rolling tool. This means we have a mechanical tool where a roll, shaped to be suitable for the thread, is pressed into the thread root and then guided along the thread. A specific rolling force, in our case 2 kN, was applied. And then we reinforce the thread again at the thread root. The thread roll is now designed to fit exactly in the thread root. It is mounted in a floating manner, meaning it can shift slightly and finds itself exactly in the center of the thread root. This has an advantage in terms of process reliability and ease of execution for the worker. As part of the project, we naturally conducted many different analyses. We made micrographs of the threads, we examined the residual stress, we looked at the hardness, but the most important aspect we examined here was the area of fatigue strength. For this, I have brought along the 3 different SN curves for you. On the far left, you see the cut thread. You can see that the knee point in the area of fatigue limit is around 65 MPa, which is already quite a good value. However, compared to the rolled thread in the middle, it is a significantly poorer value. With the rolled thread, we have a significantly higher fatigue strength. We see that the area of the fatigue limit occurs at significantly higher loads. This means that the entire level of the curve is shifted significantly upwards. On the far right, you then see the burnished thread. The burnished thread fits in here, exactly where we expected it to. We did not expect that by burnishing we could achieve the quality of a rolled thread. That would be utopian, it would be nice for us, but that is not to be expected, because with a formed thread, the fibers in the structure keep the fibers in the structure constant. We do not cut them, and thus the thread is inherently stronger. However, as you can already see, compared to the cut threads, we have a significant improvement here. Since these graphs are naturally very confusing, I have prepared them again in a more illustrative way. Here on the far right, we have the 3 different Wöhler curves once again, just the average values, not with all possible variances and scatter ranges from the Wöhler evaluation. You can see that for the cut threads, which we have considered as 100%, we are at 65 megapascals, while the rolled thread is positioned with an 84% higher increase at 121 MPa. And the rolled thread, as I mentioned, is relatively positioned in the middle. Here you can certainly play around a bit with the process parameters and optimize a little so that you might achieve a slightly higher result, but the tendency that we are approximately in the range in the middle between these 2 methods is quite alright. In this case, we were 30% better compared to the cut thread. With that, I have reached the end of this short video. I sincerely thank you for your attention, and if you have questions about these or other topics, you are of course welcome to contact me or my colleagues at ECOROLL.